Hi everyone. In this video we're going to start talking about section 1.2 which is on quadratic equations. So quadratic equations are special forms of polynomial equations, which is what we did in the past two sections. And so now we're going to delve deeper into specific kinds of polynomials and how we can deal with them. So a quadratic equation is an equation equivalent to one of the form ax squared plus bx plus c equals 0. Okay? And here a has to not be 0, because if it was 0, then this would go away, and what we'd be left with is a linear equation. And we already know how to work with linear equations, so we need that first part. Okay? We need the ax squared to be there. Okay, where a, b, and c are all real numbers. So, in fact, this is the type of equation that we worked with at the end of section R.5. So we learned about factoring these types of equations, and that's definitely going to come in with this chapter. Now, a specific type of equation or a form of this equation that we're going to want to work with is the standard form of the equation. And so that means when everything is on the left side, so at least everything with the x's is on the left side, and also any number is on the left side. The only thing that should be on the right side of the equation is 0. Okay? So that's the important thing. Everything that we're interested in is on the left, and 0 should be on the right. So now we're going to start with solving a quadratic equation by factoring. We actually have 4 different methods that we're going to use to solve quadratic equations. Okay, each of them have to do with specific forms of the quadratic equation that make it easy or hard to work with. So, when the degree of the equation is equal to 2, which is what we're going to work with all throughout this section, there will always be 2 solutions. Okay, so for every equation that we work with, the answer should have 2 of them. So there should be 2 answers. Okay, sometimes the solution may be repeated. So in fact, we only have 1, but it happens twice. So we'll see that here in a second. Okay, so the first and sort of easiest way to go about solving these equations is by factoring. Okay, and so we've worked with factoring a bit in the last few sections. So for example, in this the first example here, number 1, x squared plus 6x equals 0, the first thing that we should observe is that there's an x common to both. So we're going to pull the x out in front, and we're left with x times x plus 6 equals 0. And so this, in fact, is a form in which we can work, because we have two polynomial type things. So we have a monomial here and then a binomial here. But when I have these 2 separated things, and they're linear terms, I can say that the solutions of the equation are when either this is equal to 0, or when this is equal to 0. Okay? So that's how I can get my 2 equations. Because I know that 0 times anything is 0. So when I have a product of these 2 things, if one of them is 0, then the whole thing is 0. So the first solution is when that first thing here, which is just x, is equal to 0. So that's one solution, and you can easily plug that back into the equation to see if that is actually is a solution. 0 squared is 0 plus 0 times 6, which is 0, so everything's 0. Okay, and the second one is x plus 6 is equal to 0, or that translates to x being equal to negative 6. Okay? And you can substitute that back in as well and see that it does equal 0. So our 2 solutions here are x is equal to 0 and x is equal to -6. Okay, so there are the two solutions for that. That's sort of the nicest case. Now let's move on to 2x squared equals x plus 3. The problem with this equation that makes it a little tougher than the first one is that it's not in standard form. Everything's not on the left side. So let's put it into standard form. I want everything on the left, so I need to subtract an x and add a 3. Subtract an x and subtract a 3. And I get 2x squared minus x minus 3 equals 0. Okay? Now, you can factor by grouping if you want here to get the product of two things. Or you can try to think sort of less formally about this if you want to. We know that there needs to be a 2x here and an x here. And we know that the two things have to multiply to 6 and then add to -1. Okay, multiply to 6 and add to -1. And so we know that the two numbers are 1 and 3. We just don't know where that's going to go. Okay, and so you can try this with 1 in the first or 3 in the first. There are like two options here. But when you do the grouping, and I'm just going to move ahead for time's sake, 2x minus 3 and x plus 1 are the answers. Okay, and so if you go through and FOIL this out, you'll see that that is the correct thing. Okay, so then we again set each of the parts of this left-hand side equal to 0 to find our equations, or to find our solutions, I'm sorry. So x plus 1 is equal to 0, which means that x is equal to -1 there. And if you substitute that back in, -1 squared is 1, so we have 2 equals -1 plus 3, which is 2, so that's good. Great. And then we have 2x minus 3 is equal to 0, and then you add a 3, divide by 2, and you get x is equal to positive 3/2. Let me write that better. Okay, positive 3/2. So you again need to substitute that back into the original equation. Okay, so you have 2 times 3/2 squared, which is really 2 times 9/4, which means that you get then 18/4, which, if you simplify, is 9/2. Okay. Then, if you add 3/2 and 3, you also get 9/2. So I know I talked through that. It probably made no sense. But you need to check both of them. But in fact, both of them check out. And then we come to our last one, which is a similar thing to example number 2 here, but it's nice because it's already in standard form. Okay? Now, 9x squared minus 6x plus 1, we again want to think about two linear terms that are going to get me to this trinomial thing up here. Okay, and so we have plus 1, okay, and we have 9x, and then minus 6. So we know that the two numbers here need to be 1 and 1, because the only two things that we can multiply to get 1 is 1 in itself, which is 1. Okay, then we need to think about what terms, what x terms go here and here. And we could try 9 and 1, so 9x and then x. But in fact, that's not going to get us to our minus 6x in here. So what we actually need to do is the two terms are 3x and 3x. Okay, 3x times 3x is 9x squared. And if we add the negatives in here, 3x minus 1 times 3x minus 1, if you FOIL that out, you'll get this one here, okay, this trinomial. Now that's a little trickier to think about. You likely won't see anything this tricky on an exam, okay? But this is a special example because you'll see, and actually you could go back and look at the special factoring rules and see something like this there. But now we have 3x minus 1 times 3x minus 1, and so that's the same. If we set that equal to 0, we get that x is equal to a third for both of them. So in fact, the solution is x equals a third, and it happens twice. Okay, now we don't quite know what that means, but it turns out that x is equal to 1/3 is the answer. Okay. So that is by factoring. Now quickly, we can also solve quadratic equations by the square root method. Okay? And the square root method can only be used when we have things in the form of something like this, okay, where all the x's, or there's really like one thing in the left side that is just x something, okay, and then in the right side, where there's a number, okay? And it says that if it's in this form, then x is equal to the square root of p or the negative square root of p. So in our first example here, we have x squared is equal to 5. And so we know that if you have x squared, you can take the square root of both sides to get down to x. That's all we're doing here, okay? And then the two answers are plus or minus the square root of the number on the right side. Okay? So whenever you take the square root of something, you have to include plus or minus on the other side. So that is the answer for that question. On the right, we have something a little bit more complicated. Okay, we have x minus 2 squared equals 16. Now, in fact, it's not that bad. We do the same thing. We take the square root of both sides to get rid of the square. And so we're left with x minus 2 is equal to plus or minus the square root of 16. And remember that the square root of 16 is 4, or 4 squared is equal to 16. So now we have x minus 2 is equal to plus or minus 4. And then I add the 2 over. And so the two answers are, if you take the plus 4 plus 2, we get 6. Okay, so that's this first one. But now if we take the negative version, negative 4 plus 2 is negative 2. And so there are the answers. Okay, so that's the square root method. Now, here's a your turn. Factoring in the first one, square root method in the second. Okay, hopefully not too bad.